I'm Tim James from Hydraulic Cartridge Valves. Today we're going to look at a common issue when using multiple flow controls in a system that has varying oil supply. For example, on mobile equipment, the prime mover can run at different RPMs. This can lead to a circuit that demands more flow than the pump can supply. In our demonstration, we're using a load sense pump and running that at varying RPMs. On the business end, we have two hydraulic motors. Motor 1 is set to 10 litres per minute with a 500 psi load, while motor 2 is set to 5 litres per minute with a 1000 psi load. We'll be looking at the fundamentals of using two pressure compensated flow controls in parallel, and then compare that to the HCV solution using a custom manifold with pressure compensated flow controls, but with flow ratio sharing characteristics.
In the schematic, we can see a standard speed control setup for the two motors. Two pressure compensated flow controls are combined with a shuttle to signal the load sense pump. Remember, motor 1 is set to 10 litres with a 500 psi load, and motor 2 is set to 5 litres with a 1000 psi load. When we start the LS pump, you'll see oil takes the easiest path and rotates motor 1 first. Motor 2 with the heaviest load does not move until motor 1 receives its set flow of 10 litres per minute. At this point, the LS pump can now compensate for the 1000 psi load required by motor 2. A decrease in revs of the LS pump shows motor 2 slow to a complete stop before motor 1 slowly starts to lose speed. And finally comes to rest. Let's watch that again. LS pump starts. As pump revs increase, motor 1 speeds up. Motor 2 only starts once motor 1 is satisfied. Both motors are now up to speed. We decrease the revs, motor 2 slows and stops. Finally, motor 1 slows and then stops. This schematic shows HCV's solution to the problem. As previous, we are utilising two pressure compensated flow controls in a parallel circuit with a shuttle to sense the load. However, this configuration gives a totally different characteristic to the earlier example. We now have flow ratio sharing. As the LS pump starts to rotate, we notice oil shares itself to both motors. The pump is sensing the highest load even though motor 1 does not have its 10 litres per minute. As motor 1 has been set twice as fast as motor 2, we can see visually that this ratio of 2 to 1 holds pretty well throughout the speed range. Let's watch that again. LS pump starts, both motors start rotating. As revs increase, both motors speed up. Motors are now up to speed. Decrease in pump revs slows both motors uniformly at a close 2 to 1 ratio.
For additional information on this demonstration, flow controls, or any cartridge valve application, please contact the team at HCV. Thank you for watching.